this session, practical data modeling in Power BI beyond the star schema. So why this presentation? When we look at many examples, especially in books or training materials, we often see very clean and perfect data models. And well-known example is the composite data model, where we have a fact table with dimensions around it. And that structure works very well. It is a good starting point, but in the real world, things are usually a bit different, or maybe only where I start with a job. Different business questions sometimes require different modeling approach. And during this session, I will explain the theory, but will also show you some practical examples. So let's start with the presentation. But first, let me introduce myself. And I must use this. Yeah. My name is Peter van der Bos. I live in the Netherlands and I work as a freelance trainer and consultant. I've been working with business intelligence for over 15 years, I think, on this moment. And since 2016, my main focus has been on Power BI and the Microsoft BI stack. I help companies build better data models, and I also create training sessions and videos. My videos are in Dutch, but nowadays I add English subtitles so more people can follow them. I also regularly speak at conference and communities events to share my experience. So if you want to learn a little bit Dutch and also learn something about Power BI, follow my videos and maybe we speak next year in the Dutch language. The first question, and I think that's the most important question, is why is the data model important? And it's the foundation of everything you do in Power BI. And many customers ask me, my report is slow, can you fix it? And in 80% of the cases, the root case is a poor data model. So, and I say it's a foundation. So everything what is going wrong with the performance in the most cases is related to the data model. And sometimes I come with a customer and they show me the DAX queries they have written, and I see 35 of lines, and they are very proud, and also the values are correct, what also is important. But the only thing and I understand they are very happy with it, but the only thing what I think is your data model is not well designed. So create a better data model. Your DAX is a lot easier and simpler. And simpler DAX leads to faster reports. So I think the data model is one of the important things to have a very easy reporting and a fast reporting. If you have a lot of complexity in your data model, also the results are very slow, and you need a lot of DAX to get the right results. So in many models, I see the same problems, and they are usually not technical, but modeling decisions. And the three common issues are first the grain, and everybody know we need the right grain, but it's very difficult to have the right grain in your data model. And I think this is the most important question. And this is the first question you ask yourself: what is the grain? What is necessary to build a great data model? So you must start with the question, what question must report answer it? And don't assume the stakeholders' questions. And yeah, I make I make that also a lot, this problem. I think for the stakeholders, and then I create a data model and they say, yeah, but it don't give the answer to what is necessary for the report. So be careful with that. And if you have the wrong grain, you also, in the most cases, you choose the wrong fact table type. So we have different fact table types, and I show you later in this presentation the important fact tables you can use in your data model. And the last one is the many-to-many. And I see some relationship with the many-to-many. And yes, Microsoft have created the many-to-many relationship in the data model, but don't use that. And I'll let you show later in this presentation how you can create a very strong relationship, not a to many relationship is very weak. You don't want to use that. So first, the basics. Yeah, the basics are very important. And why? The engine of Power BI, the Vertipack engine, is built to use with star schemas. So we need a fact table, we need the dimensions. And if you have this foundation created, you have a well-designed data model. And it's not matter which fact type you use, but the star schema is what you need. And we have two different table source in our star schema. There's a fact table. We have the contained the fact representing an event with dimensions. And we have a dimension table, and that describes attributes of entity such as a product or a customer. And sometimes you must make a choice. You have a column in a table, and is it for the fact table or is it in the dimension table? And I have a very easy rule of thumb. If the values in the column are, can I put it on a bar chart, in a bar chart on the axis, then I know it's a dimension. And if it is in the bars, I know the column is a fact, once I want to calculate with it. So that's a very easy rule of thumb to make the right decision where a column is stored, in the fact table or in the dimension table. And yes, we have a little bit different schema, and that's a snowflake, and that's a variant of the star schema. And I used it not a lot, but if I use it if we have a dimension table with a lot of columns, and that is very poor, and that gets a very bad compression on the table. So if I have a very big dimension table, then I want to split it in a different dimension table. And that's the only use if I want to create a snowflake model. In the most cases, it's not necessary. And for the performance, a snowflake model is not bad, but a star schema is always better. So it's a possibility. And that's the basic for building a data model. But we have different things you must know. And the first thing is we need the grain. And if we know the grain, we can build the fact table. So the most important step in the data modeling is define the grain. And this happens before you start building the model. And yeah, I know if we have the data, we want to create a data model, and we are very good in that. But one step back, first search what's the grain for your data model. And that's, you need that before you're creating relationship, before writing docs, before even building the fact table. So you must first understand what must the report show, which business questions need to be answered. If you know that, you can make a right decision how you create your data model. And the business questions define the grain. So for example, when we are daily sales per product per store, we have the grain is one row with one product in one store and one day. So a grain is not a technical choice, it's a business driven decision. So we must understand what is the grain, what is necessary for the report. And if we don't have the right grain, we have a mismatch leads to incorrect numbers. For example, if we have a monthly target and a daily sales, the target is on month level and the sales are on day or transactional level. So we have two different grains, and if you relate them directly, then we have the monthly target repeats every day. So the totals get inflated, and you don't want to show that in your report. Nobody understands what's happening. They know what's happening, but it's a wrong report, and you don't want to give your stakeholder a wrong report. So how we can choose the right granularity? Start first with the business questions. Ask what question must be answered and what decision must be supported. So, and a key rule is business questions define your grain, and the grain follow always the business questions and not the available data. If you create a data model with a lot of data, and we try to give an answer to the question. In most cases, it's not always possible. So start with the data and then try to answer the questions. Sorry, that's the common mistake. Start with the data and then try to answer for the questions. So a better approach is start with the question first. A model gives answers, and that's very important on the business question. And if we know the grain, we can make a decision about the fact table, and we have different fact tables. So there are three kind of fact tables they use the most in the business intelligence world, and that is a transaction fact. And we know that that is the fact table in the Contoso data model. And we have one row per business event. That's are very detailed, and this event drive data. Then we have a snapshot fact, and that is one row per entity per time period. For employees, we see on a certain date, we have so many employees in our company. So also later for this, I give an example. Then we have the accumulating snapshot fact, and that is one row per process instance. So it tracks milestones within a life cycle. So we have everything on one row. So let's try some examples. I have an example, and that is sales. And if you want to know total sales per day, the grain is day, and not every individual transaction. And one row represents sale at the required report level. So I have here the transaction fact, but I have also a demo, and I like it a lot more. So in this case, it is the Contoso data warehouse. So if we understand what is happening here, we have a store, a dim store, and fact sales, and the dim date. So the question was, we want all the transaction for one day. And if we go to the fact table, we see for every transaction we have a row. So that is not what the business question was. So if we want to have fact table, what is the right grain, we go to transport data, and if I duplicate the fact table, and I do it on the easy way, I group by, and I use date key. So we have all the total sales on the date key. I have a new column name. And we have a sum, sales amounts. Okay. So we have now a fact table. What is the right grain for the business question? And I use also the fact sales. So if you want a deep dive in the transaction, then it's possible. And normally I did this in Power Query, but you want that to do in your data warehouse and not in Power Query. So if it is possible, do everything in your data warehouse. So close and apply. And then I hope everything is going well. Yes. And what's changing? We have one table extra in our data model. But if we go to the rows, we have 100 rows in our data model. And if you go to the fact sales, if I see the rows, it's 3.4 million. So we see we have a very small fact table, so the response in your report is a lot faster. So that's also very important to use the right grain. If you have a table with a lot of rows, it costs time to summarize or sum a column. And it is sometimes possible to a smaller fact table with less rows to get a very fast response in your report. There's also what I sometimes do with customers if they have a table with many billion rows, and they want to have on the first report they want to have the sales on a day. I create a fact table on a different level, so that is the fact table to show the measures on the report. So that is very, dus the report is loading very fast. Why? We have less rows in our fact table. So that is one of the important thing to choose the right grain and give the right answer to the business question. So example 2, and that's employees. And in this case, we want to know how many employees we have on a specific day and in which department they work. So the grain becomes employee, day, and department. And we have one row representing employees and one specific day in one department. Now, I have also a demo for that. In this case, we have the employee snapshot. And maybe I can zoom in it a little bit. So what we have here, we have for one employee, we have one row for every day. So that is repeating for every day, and that is the snapshot moment. I also give the name from the column always the name snapshot date. Why? Then it understand everybody this is the date for the snapshot. So it's a little bit easy for the business users. They know what I understand, and if they have a report and they don't select a date, they get very wrong values. I hope they understand the values are over the complete period and not only for the specific day. So, and we have the date key, and we have an employee key. And then we have two columns with FTE and headcount. So it is very easy to measure how many employees we had on a specific day. And in this example, I show the report. We have also tracking on it with the slowly change dimension. And later in the session, I explain also the slowly change dimension and how that compare with the fact table with the snapshot. So why everything work together, and we have a right historical history. So I have showed the snapshot fact table. Then the last one, that is an order process. So if we want to analyze, we want an order, we want to know when an order was received, when it was shipped, and when it was delivered. And the grain is one order. So there's a different approach. Not for everything what is changing, we get a new row, but we put it on the same row. And so every milestone is on the same row, and we can make there the calculations on that. And so in this case, we have, and I focus on one row. We have an order key. So we have a customer, and he ordered a certain product. And we have the order date key. So that is the date when the order have taken place. Then we have the ship date key. So that's a different milestone. We shipped the order to the customer. And the last one is the delivery date key. And that is when the customer received the package of the order, what he have ordered. So in this case, we see every step in the process, and we see also for orders where we don't have delivered yet, we see also an open value, or it's not, we have no dates there. And we can use for every order date and ship date key, it is possible to create a relationship. So in this case, let me. So we have different relationship, and one of the relationship order date key is active, and the rest of the relationship delivery date and ship date is not active. We can make it active with the DAX function use relationship, and we can write DAX queries, so we can make the count of the many days what is between the order date and the ship date or the delivery date. But there's also an other approach, and that I use that a lot. And the reason is, then I calculate it in my data warehouse, and I don't need create a DAX query to create of see the days between the different dates. And also, yeah, I have 2 columns extra in my data model. And I always say less columns are better, but the compression on that days are very easy, and it is a small cardinality. So you have not a lot of unique values. So the compression is very well on that column. But we can also use a very easy DAX query for that. If you want an average, you can use the average for the DAX query, and you get the certain period where you can see which period, what is the average from the days to ship or the days to delivery. So you can create a very easy DAX query. And yes, it is possible with a DAX query, so you don't need the columns. It's a little bit more difficult, but for the performance, I use this a lot, so I know the performance is a lot better.
Peter?
Yeah.
We have a question coming in, and I was expecting this one actually. So the question from Renat is, hey, if there are multiple business questions which needs to get combined into a single report, what if those questions require a different grain? What is a good practice to have the same fact table with different multiple grain? Well, with different so what would you do? Would you have one fact where you would try to calculate all metrics on, or would you separate fact tables based on the grain?
Yeah, I separate fact tables on the grain. Why? If you have a fact table with different grains and you have different dimensions, I think that's the biggest chance to get a wrong value. So I separate the fact tables and the dimensions, and I use a different approach to get a dimension on the right grain. Maybe sometimes I create different dimensions, not in the most. I try avoid that, but sometimes it's necessary. But split always the fact tables in the right grain. If you have for example, you have the sales table and also your budget table, and the budget is on month level and the sales is on day level, it's not compared with each other. So split that in different fact tables. So I hope the answer is clear, and so not I see in the chat your response.
Perfect, thank you.
Thank you. So that was the last snapshot, and then the slowly change dimension. And yes, type, and there's a little bit the teaser. Type 2 is the thing we use a lot in the data modeling, but I want to explain what a slowly change dimension is. And it's very I have searched on Google and Bing. Yeah, I use sometimes Bing. What's the most asked question about data modeling? And that is we have a problem with the historical date to get it on the right shape in our report. So that is one of the reasons I want to show you the slowly change dimension. That can help you with the report on the right level, but also your history is right in your reports if you go to the past. So up to now we focus on the fact table and we declare the grain and we choose the correct fact type. But even with a perfect design fact table, we can still get incorrect historical reporting. And the reason behind that is because dimensions are changing. Employees change to departments, products change in categories, or customers leaving the country. So things are changing in your dimensions. And it's necessary to store the changing in your dimensions, and we can use slowly change dimension for that. So if the historical is not right, in the most cases the fact is correct, but the context is wrong. And that's exactly why slowly change dimension type 2 exists. So what are slowly changed dimensions? And there's a dimension that change over time. And what is a dimension what change over time? Maybe you are a sales manager and you work in the Netherlands and you change to France. So you have changing the dimension. So your name, in my case, Peter, is working in the Netherlands and I move to France. That's my new sales area. And normally, is that not a problem? In the dimension, if we change that, we override the country and everything works fine in the dimension. But if I have a bonus, and that's very important, and the bonus is depending on the sales in the Netherlands and also in France for my period, then it's necessary to have a dimension where we see the change from the Netherlands to the France. But sometimes you have also a slowly change dimension, and slowly is not the reason why we say it's a slowly change dimension. It's not, if you change very well, then is it not slowly. So in the most cases, it is things what is sometimes happening. Like you get a new job title, or if you're married, you get the last name from your partner. That's changing in your dimension, and then you must ask yourself: is it necessary to, if I'm married and my last name is changing, is it necessary to overwrite the history or preserve it? And that's a choice you must make. That's the core question: is it necessary to overwrite the history or preserve it? And we have 3 types of slowly change dimension. And the first,
sorry to interrupt. Before we we get to the different types, which is very relevant though. We were having a a bit of a chat in the chat window where some more questions popped up while you just started explaining everything about SCD. So just because this is still about the fact tables, first question is, can you elaborate on the different dimensions for different grains? I'm not sure if that wouldn't take us too far though, but
let me check the question.
Yeah, it was more about the answer that you gave with the example of the daily sales in comparison with monthly sales. That you said, hey, we will be using different facts and then different dimensions as well. I think that was the context about for that question.
Okay, yeah. The approach is, if you have a sales table where you have every transaction every day, and you have a budget or a target on a monthly level, you don't can compare that with each other. In that case, you must change something in your approach. So in the most cases, you have the total sales on month level, so you can compare that with each other. So in that case, I create what I show the fact table, and I create it on day or month level. In this case, month level, so you can compare the periods with each other.
That's a great example.
Thank you. But there's also another way, and that is divide the monthly target to a daily target. And yes, you can divide it with the days of the month, but you can also have in the history you see how I must say that you see the trend of the sales. So maybe you have a lot of sales on the end of the month, so you can use that to get a percentage for your target or your budget. So you can divide it with that. So you get a trend analyze, and then you can compare on daily base. So that's a different approach and what is necessary for your report. And then I come back and I repeating myself too many times sometimes. But what's the business question? If they create a target on monthly base, but they want in the report compare that for every day, yeah, something was changing in your data model. So I think that's the best approach. Ask what the business want, and if they want to have compare on monthly level, then that is the easy way. And if you want to compare that on daily basis, then you must use some math to create the right targets.
Okay, thank you. There's another question as well. There are a couple, but we potentially we won't be able to get through them all though right now. But one more though is so if you take a look at accumulating snapshot fact tables, if there is some audit data included as well, which will be a smaller data set because only a few hours will be audited. Does the audit data needs to be in a separate table, or will it be fused with accumulating snapshot fact table?
No, it's used in an accumulating snapshot table. And also here is the grain very important. The grain is in this case, let me zoom in, is on order base. So we have a customer key and product key now, and we have the dates, that's the dimension date. So in this case, if you want to have, and this is a very simple approach, we have the days to ship and days to deliver. We have also a status. So we can choose the right approach. The dimensions here are on the lowest level. We have customers. Customer is gewoon one individual row. And also the product keys are an individual row. So the dimensions is not depending in this case for the milestones we reached with every row we have in this snapshot table.
Perfect. Yeah, I will be keeping the other questions about accumulating snapshot fact tables as well. When modeling a process in accumulating snapshot fact table, how do we handle workflows that aren't linear? Oh, wow. If it's bringing us too far, just let me know. We can park the question for the end as well.
Yeah, let's pause this question for the end. So I repeat, I go through with my session. And if you don't time for that, you can always send me an email so I can repeat on that. So no problem.
SCD type 1, 2, and 0.
So the three types of slowly change dimension. So the first is type 1. That's it is overwritten. So the old value is replacing. So for the example, what I have, I'm sales manager for the Netherlands, and I change to France. So the country is overwritten with that information. But in that case, we don't have an history preserved. So we don't can connect on a certain period why people have sold a lot in the Netherlands or in France. So I don't use it a lot. I think this one of the types never use that, and the reason is if I have a dimension with a product and the product is changing, why I want to have override that product? In this case, I want a new row with a unique key with the product name and the reason why it's changing maybe, or a new product name. So it's very clear what's happening in your data model. So that's type 1. Type 2 is the most used, and that is preserved history. So for every new thing in your dimension, they create a new row for each change. So we have historical versions are stored, and fact links to the correct version. And I show you late in this presentation an example, so we see how it's work. Then we have type 3, and that's a limit history, and this in previous value stored in an additional column. So you are depending from the columns you have, how many history you have in your table. It is possible to have multiple columns, but then it's very complex to use in your data model. So, and also this type, I don't use it a lot. I think if I think about it, I think I use it never. And the reason is you have a limit history. Why you want to have a limit history? On this moment, I have never seen a case where I can use that. So back to the most important slowly change dimension, type 2. Yeah, what it does: preserve history by creating a new row per change. So each version gets its own surrogate key. And yeah, I can read the sheet for you, but I can also give an example. So in this case, I have a slowly change dimension, and I hope I can zoom. No, that's not very helpful. Okay, in this case, let's focus on one employee. That's Jan de Vries, a real Dutch name. And you see employee key. So what's happening with Jan de Vries? Jan de Vries is starting with the company on the 1st of January. And we see that with the start date. And he starts on the 1st of January, and he starts with a job planner. We see he have an employee business key, and that's the same. So that's not changing. If this is changing, then you must go with your data model to the drawing board. Then is there something very wrong in your data model. So, and after a period, he's changing with job. So he had a new job. He's team lead, and he changed that on of the start date is the 1st of July. So we see an end date. And the end date is very important. So we close the row. And also in this example, we have is current. So if we have false, then in this case, the row is not active more. So it's historical. But we see in the new row with the changing of the job, we see the employee certain key is changing. So we have first, we start with employee key 1, and the second row is employee key 2. And that is how slowly change dimension 2 is work. So for every new job you have in the same company, you get a new row with the employee key is the same, your name also, the job title is changing, and we have the start and end date. So I built in the most cases the fact table, so the snapshot fact table. My foundation is the slowly change dimension, and I create that in my data warehouse. So what's happening if we use that in the data model? I've here the snapshot table, and I've shown you that earlier, but we have here a snapshot date, the date key, the employee key, and the FTE and the headcount. So if I go to the report, I've selected Jan de Vries, so I have a filter on his name. And yeah, normally we do that on an ID, but sometimes I make a mistake with that. So he starts on the 1st of January, and we see for every day we have a row in the table. So the grain of this is every employee for every day and the department. So if I scroll down, we see all the days he's planner. And yeah. And the 1st of July, he changed from planner to team lead. So we can see the path he followed in the company. So we see also, if you have multiple job titles, we see also that happening. So we can also make a calculation on how long is everybody in his current job, or when they want to switch to another job. And I have the headcount calculated. Okay, use a wrong demo. So, and if I need the headcount, I can use only the column with headcount. We see all the headcounts from Jan de Vries. But on the total, we count everything. He summarized all the values. He summed the values, and that's very important. If you use a snapshot table, the date what is using is important for the filtering. And why? What I mean with that? If I use this table and I have the department and the job title and the sum of headcounts, we see a lot of numbers, figures. But this is not correct. We sum all the headcounts on the row. So if I choose now a date like the 6th of January, we see on that moment we see we have 9 employees. We have 2 employees on the logistic, like the planners. So, and we can see what's happening here. And sometimes I get the question, yeah, a snapshot table is very great and handy, but I get a lot of rows. And for every employee, I get a new row for every day. And if I have 10,000 employees, I get 10,000 rows for every day. And how is that with the performance? And I think the performance, and I've tried that, performance is very great if you use what I have done in the table, a column with your FTE and your headcount. So it's a small figure, and you use only the sum to get the right results. But some people say, yeah, but we can also create that in DAX. Then I need a big table, a fact table, and is that faster? Now, let's try. I have this table on the 6th of January, and I have also the performance analyzer. I clear the cache and refresh the visualization. So it's take 121 milliseconds to create this table. And yes, we have 6 milliseconds for the DAX query, but total it's 121. So I have also an example for the snapshots here. And so it's worked the same. I use, in this case, a DAX query where I calculate the employees with a filter for the period. So it's a little bit more complex than a sum, but it's not a very complex DAX query. So if I use that, and also 6th of January, I go to the performance analyzer, clear, refresh visualization, and we see it's a small difficult, it's a small different between the tables. So in the first data model, I have a lot of rows, and in the second data model, I have not a lot of rows. I use the slowly change dimension. Very strange sentence, but okay. I hope you understand that. And we receive the right values. So this is a choice you must make. But one of my favorite is the snapshot table. Why I have hard numbers, and I don't need a lot of DAX queries to create the right answer on the business question. So that is the reason why I use slowly change dimension. Are there questions about the slowly change dimension?
Currently, no questions.
Oh?
No, you actually answered one of the questions throughout your demo. So
okay,
no.
Perfect. So, and the last one, what I want to tell you is the many-to-many relationship. And a many-to-many relationship exists when one value in a table relate to multiple values in a table B, but also otherwise. So a normal, we see it with banks. If you have a bank account, in my example, I have a bank account with my wife, but I have also a personal bank account, and my wife has also a personal bank account. So if you relate the account holders and the accounts, we have a many-to-many relationship. And a many-to-many relationship is a very weak relationship. It creates an ambiguous data model. Why? You don't can follow the relationship in the same how you use also the one-to-many relationship. So it's a little bit ambiguous, and I think yeah, they must delete it from the Power BI environment, so we don't use that. But in a proper star schema, we have a fact, and that is connect with a relationship to the many, and dimension is always connected to a fact table, and that is the one side. So a dimension is unique, and a fact have multiple keys. I hope if you have sold a lot of products. And where we see a lot of many-to-many relationship, now I give the example from a bank, but budget versus sales and shared ownership. And in the most cases, this is a grain mismatch. So the mismatch, the reason from the relationship is the mismatch, and that's the problem. So, and we get ambiguous filter paths, and sometimes also the values, the calculation are not true. So you get wrong calculations. Yeah.
I was going to ask questions, then I thought you were going to continue quickly. No, there actually are two questions. I'm going to start potentially with the easiest of the two, though. What about many-to-many relationships, but cross-filter direction on single? Is that a good idea?
No. And the reason behind that is your data model gets ambiguous. Okay, I don't prepare that, but I think we. How many time we have, all of you?
Well, we have plenty of time, in all fairness. It is a virtual meeting, so.
Okay. Let me show you an example. Give me 1 second. I have too many demos. Yeah. So why I don't no. in one case, and I show the case later in the session, you can use a bidirectional relationship. But in the most cases, I don't want to use that. Why? Your data model is getting ambiguous. So, and what is ambiguous? I show you this report, and this report is the inventory on the 1st of January. So we have in the inventory, we have 100 apples, 100 bananas, and 100 orange. And if you go to the 2nd of January, we have 50 apples and 50 bananas. So this report is working perfectly, and everything is okay. If I go to the data model, we see we have a date and we have the inventory. So we have a relationship between the date and the fact inventory, and we have the right filter direction. So we go from 1 to many, and we filter to the fact inventory. So that's the only way he can follow the steps and the relationship in your data model. It is not possible to go to a different way, a different relation path. If we follow this step, we go to the fact sales, and we have a filter direction here from the dimension product to the fact sales. So it's not possible to follow the relationship between the fact sales and dim product, but I can change that. So I change that to both relationship. And if I go to the report, all the figures are correct. And the reason why, Power BI follows always the shortest path to the table. So in this case, he follow the date to the fact inventory. So in this case, I think if you try it 1,000 times, the report is always correct. But if you have a lot of fact tables in your data model and you have more a bidirectional relationship, your data model gets ambiguous, and normally you get a warning, but sometimes it's so complex, also Power BI don't react on it and accept the change from bidirectional relationship, but your data model is ambiguous. So let me show you what happens if you have an ambiguous data model. And we help the data model a little bit, we delete the relationship. So in this case, we go to the report, and what we have in the report is we have 50 apples on the 2nd of January, and we have 100 apples on the 1st. And I can choose also 2nd of January, but we see nothing happening. If I choose the 3rd of January, then we have a blank report. We have no values on that date. But what's happening in this case? We have the date, and if I go to the date table, we choose the date, the 1st of January. So we have a filtering on that table, and we follow the relationship. So we go with the filter from the 1st of January to the fact sales. If I go to the table with the fact sales, we have the date, and that's the 1st of January. So we propagate the date from the date table to the fact sales table. And on the 1st of January, we have sold one product, and that are apples. So in this case, we have a filtering on the date, not yet on the apples, but we go through this relationship. We have a bidirectional relationship, and we reach the dim product. On that case, we have two filters. The one filter is the apple, and the other filter is the date. So let's go to the dim product. We have in this case no date, so the filtering on date is removed from the table. But we have only one filter, and that's apples. So in this dimension, we have only filter on apples. So we go to the next table, and that's the fact inventory. And what's happening in the fact inventory, and I think you understand what's happening. We have a filtering on apples. And we have only two rows in the fact inventory. we have 2 rows with apples, and that's on the 1st and the 2nd of January. So we have the 100 apples and the 50 apples. And that's happening if you use a bidirectional relationship. So it's a little bit a long answer, but that's the reason I give you the advice, don't use bidirectional relationship. And I know in the past, I think it was Alberto Ferrari, he always say, if you use bidirectional relationship, you go to hell. Now, this may be a little bit too much, but you make your data model very complex and ambiguous, and you don't want that. Then you say to your customer or your stakeholder, yeah, in most cases, the report are correct, but sometimes you take the wrong path, and in that case, you get wrong calculations in your report. I don't want to say that to my customer, so I hope you also not. So that is the reason, don't use bidirectional relationship. But there is one solution where you can use that, but I'll tell you later. So there's a little bit of teaser in the session. I hope I give the right answer to you.
Yeah, perfect.
Okay. So with the many-to-many, no, we don't use a bidirectional relationship. To the sheets. So Power BI support many-to-many. That does not mean you should use it without understanding the consequences. So in my case, never use the many-to-many. You get a weak relationship. So, and you have also risk in the values. They are not correct. And why? Let me start with the demo. I like that a lot more than the slides. In this case, we have a relationship, we have a many-to-many, and yes, if you have a many-to-many, it's changed to a bidirectional relationship. And you can change that to a right filter, but then everything is broken. So it is a possibility. In this case, if I have the author name and the title, we see we have the definition guide to docs. Everybody know that book, I hope, from Alberto and Marco. And we have the sum of the revenue. So what's happening in the data model? We go through the this dim author. We have a relationship between this dimension to the book author, and then we go to the fact table, and the fact table have book ID. So it is possible there are multiple book IDs, we have multiple writers, and if we change this and we drop the author name, everything is working fine. But if you know the author name, we have a problem. So with the many-to-many relationship, we have a problem, and we don't have the right revenue. So we must change that. And now I have changed that. I have here an example where I use a bridge table. I advise in all these cases use a bridge table. A bridge table is between the dimensions, and yes, this is also a design problem. In this case, we have a fact table with book sales, and we have book IDs, and why you don't have a column with author IDs. So we have 2 dimensions with the author of the books and the book name. So you can filter on the right approach. But if you have a right approach, I can explain how many-to-many works. So if you have a many-to-many relationship, you want to have a very great relationship. So one-to-many, create a bridge table. And in the bridge table, we have the numbers of the IDs of the authors and also the IDs of the book. And they combine with each other. So we can create a relationship between the dim author to the bridge table. And then we have a one-to-many. So it's sometimes they call it a factless fact table. I'm not sure if that the right name is. So I call it always a bridge table. So, and we have the book ID. So we have all the unique book IDs, and we have create one table for that. And in a normal case, and I forget to change this. So we have a unique value. So this is a dimension, this is also a dimension, and that filtered to the bridge table. So, and that's how it's work on a normally way. And in this, only in this example, you use a bidirectional relationship. Why? If you don't use a bidirectional relationship, we come from the dim auteur. We follow the path to the bridge table, and in that case, the relations stop. So it is not possible to skip this filtering. This filtering is to the dim book, to the bridge book auteur. So if we change that, it is possible to go through the bridge table, through the dim book, and we reach the fact book sales. So in that case, if we use it on the right way, the sum of revenue is also wrong. But the path, we have a weak relationship, many to many, and we change the relationship in a very strong one, a one to many. And yes, the revenue is wrong, but if you change that with a DAX query, so in this case, I create a very easy DAX query where we have we count the writers of the book, and we divide it to the writers. So we see the right values and also on the total line. So this is how you must work with a many-to-many relationship. But in the basic, a many-to-many relationship is also a wrong decision in your data model. The grain is not on the right way. Not only the grain, but also the drawing of your data model. So if you want to have a proper data model, also with this, what I say, split the dimensions if it is possible and create it to a fact table so you have a proper star model.
Peter, I have
yeah.
one more question, and I actually believe you already answered it in the previous slide, though. Is it good practice to use a bridge table if you generally have a many-to-many relationship between dimensions?
Yes, you must create the bridge tables. So yeah. Skip, please, the many-to-many relationship. Your model is so ambiguous, you don't want to have that. So, yeah, I have explained everything about the many-to-many. So the best practice, what I want to give you with this session is define the grain first. And yeah, I know it's common sense, but in the most cases, I see they start with creating a data model if they only know the data. So choose the right grain and ask for the business questions. What is the business questions you want to answer it? If you know that, choose the correct fact table, dus transaction, snapshot, or the accumulating. And if you choose the right fact table, always build a star schema. So you have the right and the proper data model. And please serve history with the slowly change dimension type 2 and when it is needed. It is not always needed. If you have a dimension with only the products or the stores, maybe stores can changing with the address, but in the most cases, it's not always necessary. It's for certain business cases. So avoid the many-to-many relationship when possible. Create a bridge table and fix the grain before fixing relationships. I see in the most cases they change the relationship to fix the problem, but the problem is in your data model, in your table. So that are the best practice I want to give, and I show all. I published this presentation. I don't know if they sent it, but in my GitHub you see also this presentation, so you can always see that later again. If you have questions with this session, you can always email me. But thanks for attending, and use today's tip in your daily work. Build a clean and a high performance model. So and feel free for ask questions.